Okay guys, welcome back to my channel, and I'm going to uh, give tutorial with chapter 7, which is the IP addressing. So chapter 7 is all about the IP addressing and its elements and subcomponents. We have the IPv4 network addresses, IPv6 network addresses, also the connectivity verification. So just a brief introduction for the chapter 7. So the chapter 7, IP addressing. Addressing is a critical function of network layer protocols. Also, addressing enables data communication between the hosts, regardless of whether the hosts are on the same network or on different networks. Both network protocol version 4 and version 6 provide hierarchical addressing for packets that carry data. So for more for my explanation about the IP addressing, as far as I know, the IPv4 is the oldest one, and the IPv6 is the newest version. So in the Philippines, IPv4 is the common choice for the Filipino people, or especially for the Filipino ITs, and as well as the IPv6. But the IPv6 is more complicated than the IPv4, so that the beginners didn't recognize it as well. So the IPv4 is more usable. It is both of them is usable and efficient, but the my vote that is for the IPv4. The IPv4 is more budget friendly and more device most recognized by the device. So, and upon the designing, implementing and managing an effective IP addressing plan ensures that the network can operate effectively and efficiently. So let's start with the network addresses. We have the so-called the binary of the IPv4 addresses. So working with binary numbers can be challenging for easy one-by-one people. IPv4 address are commonly expressed in dotted decimal notation as shown in figure 2. Then, as you can see in this figure, they are all distinguished that it can be LAN A network addresses and the LAN B network addresses, and as you've noticed, they are both using, or they are running through a binary transmission. Then for the figure 2, here as you can see, it has the IP addresses as well, and its prefix notations, or its maximum hosts, and its connectivity. Then to its binary to decimal conversion, to convert a binary IPv4 address to its dotted decimal equivalent, divide the IPv4 addresses for 8-bit octets. Then next, to apply the binary proportional value to the first octet binary numbers and calculate accordingly. So as you can see here, from the so-called as positional value binary number, we calculate and add them up, and it's the result. So here at the figure, as you can see, we have all the having 1 and 0, the upper and the down part. So the upper part is all having indicates with 1, then 0 is the lower down part, and then all that up part with 1 should be added, and in order to find the result or the numbers needed. So for example, I have the 128, 64, are both signifies with 1, so let's add 128 and 64. So the answer is 192. So it's the result. It's just a simulation of getting the getting the decimal value through its binary. So as well as the figure 2 and the figure 4, and just finding or completing the IP address using the dotted decimal notation. So let's try an activity here. So here are the basic components of converting a binary to decimal. So these are the elements that you need to know. So first, you should add numbers which with 1, then you ignore those signifies as 0, those zeros. So for example, at the activity, so our need to enter a decimal answer below. Then we have 1 signifies the 128 position, and the 1, so we could add 128 plus the 1, and 2 who signifies with all 1, so 128 plus 2 was to 130 plus 1 was to 131. As you can see, we are correct with our answer. For finding the decimal value, its binary, you should know how to read its binary form. So in order for that to because its binary form always start with 1, followed by 2, then 4, then 8, then 16, then 32, 64, 128, and so on, so forth and so on. So you will start in the 1 from substituting the binary numbers. It should be start with 1, followed by 2, then 4, 8, 16, 32, 64, and 128. And for those who are with 1, for those binary having 1 number, so you should substitute it with its position. So let's try it again. So we have here the 2 having 1 on its bottom, 4, 8, and 64. So just add it. 8 plus 2 equals to 10 plus 4, 14 plus 64, we have 74, 78. So it's correct. So let's find another activity here that will suit your knowledge need. So here at this point we have the decimal value So we are going to find its binary value. So again, we're going to use this format using 1, 2, 4, 8, 16, 32, 64, 28, and 28, and so on and so forth. So we are just going to substitute. So we're going to find the 26. So our numbers, we should add the numbers. So I'm going to start adding 16 plus 8 equals to 16 plus 8 equals 24. Then the number we need to find is 26, so we just add another, we add 2, so now it is equal to 26. So now finding the position we used 16, 8, and 2. So we're going to write down that they are 1 and others are 0 because they didn't use it. As you can see, it is quite simple, the converting decimal to binary. Let's check. Okay, it's correct. In addition, for the IPv6 network addressing, so IPv6 address representation here, we have the so-called hexstats, or the binary portion is converted into hexadecimals, which we call the IPv6. So the IPv6 addresses are 128 bits in length, and it is written as a string of hexadecimal values. Every 4 bits is represented by a single hexadecimal digit. So for a total of 32 hexadecimal values as shown in this figure, and at the figure 2 as well. As you can see here, the decimal point, the binary conversion, and the hexadecimal. The hexadecimal and the decimal is quite similar, but